Hare Krishna. Hope you are doing well. Let's get started with this question on the computation of the variance of the product of a vector multiplication where the setup is IID. Okay, so you are given two vectors and they are sort of multiplied with each other. Now, I really want to take the time and show the vector multiplication because it has been my understanding that it's slightly confusing at times. So when you are given a vector transpose like this, it's a row vector, and the normal vector as it is a column vector. That's the standard notation. And here the order of multiplication would be such that the first element over here gets multiplied by the first element over here, so on and so forth. So essentially you see there is a slight pattern that z1 gets multiplied with z64 plus 1, z2 similarly with z66, which is 2 plus 64. So there's this pattern. This is the product of the vector multiplication. Now what you can do next is, you know that this expression was this thing, and notice that each like if I consider this as one unit, there are 64 such units, and each of them are going to be independent of the other ones. Why? Because each of them are containing unique variables, and we know that all the variables here are independent. So we have this thing, and then we break down the variance into its expression like this: expectation of square minus square of expectation, basically. And now the unit which has two variables in it, they also are independent. So this can be written as this can be written as this, and again it's the simplest binomial variable possible, which is Bernoulli half. So this translates to this, and we get the answer. So we solved the question with build some intuition. There was theory of independent setup, but where was the pitfall? The pitfall could have been had you gone this route. Like, you may have studied in your linear algebra towards the end with stochasticity that whenever there is a structure like this, something you have variance of y curl, and then this thing is there, and you may sort of try to attribute that to this in the moment of exam. But it's a good thing to first check what is that scalar product itself. If the scalar if the scalar of the vector product, if the scalar is dealable, in the sense it is looking IID enough because each of these units are independent and they are built from identical variables, so it should motivate you to use this method than going a more complicated route, which could be a big pitfall. Because here a curl is a scalar, it's not even stochastic. Here only y was stochastic. So yes, this could have been a pitfall, but it was not. So take care. Hare Krishna.